Alright, so in this video we're going to cover the empirical rule, z-scores, and percentiles. So let's begin with the empirical rule. So first of all, what do we mean by empirical rule? So it's a rule that we are in a way take it as it is. Do not ask how it works, why it works. We just gonna buy it. I mean, there's a big justification. It's a more fancy. But I mean, for our purpose, we are just going to use it. So this is useful. Actually, only works rather when the data set that we have is normally distributed, which is like this. And you might have seen a little bit of this type of trends before. For example, this is very common when exams. Typically the average score in an exam is like a 70. Okay, and then on this side we have the highest scores, which typically is not too many, and on the other hand we have on the other side like the lowest scores, which typically they're not too many. So the majority of the people in general, I'm not saying it's a rule in all classes, but typically the exam scores are typically normally distributed. And we are going to use, for example, what if I know that let's say the mean score of an exam at a statistics class is 70 with a standard deviation of 10, for example. So we are going to use this empirical rule to find out how many people obtain between 70 and 90, and it's going to be these two percentages added up together. So, well, the example that I have for you doesn't have anything to do with exams, but rather with weights of goldfish. Okay, so we have goldfish in a tank. We don't care about how many goldfish. The thing is that it is known that the mean, and notice the symbol I'm using the symbol for population, not for sample, because we're talking about all the fish in the tank. Okay, so all. Okay, in this case this speaks about population. Let me write that down. Would be a good idea. Not a sample. Okay, and we know the mean is 12 ounces with a standard deviation sigma, lowercase sigma, of 2 ounces also. I'm going to meet the units in when I'm labeling this. Okay, so this means that the right in the middle, we are going to have number 12, the 12 ounces. And then if I move one standard deviation, I'm going to add, so let me refer to this. From here to this, I'm going to add one standard deviation. That is, I'm going to add 2. And then for this label, I'm going to add 2 standard deviations, or I'm going to add 12 plus 2 plus another 2, which is going to be actually 14 right here. This is going to be 16, and then 18. All right, and then 18. So that's 1 standard deviation, 2 standard deviations, 3 standard deviations, and well, a bunch of outliers here. All right, so if we go in the other direction of the bell, we're going to subtract otherwise 1 standard deviation. That's going to be 10 ounces, 8 ounces, and 6 ounces. All right. Okay, what about this? Okay, let me go back to this diagram we have at the top. So it means that within 1 standard deviation, right and left, we are going to have 68% of the data. So for example, if we come back to the example of the exam, that means that about 68% of the students got, well, if the average was a 70 with a standard deviation of, say, 8, that means that 68% obtain between 62 and 78. Okay, we're going to look at more examples. We're going to apply an example with goldfish. And then if we consider 2 standard deviations, we are going to have 95% of the data. And then if we add more, these little tails right here, we're going to add 99% and so on until we get 100%. Again, because this is an empirical rule, it's not going to be perfect. It's just to draw an estimate, okay? For example, and it is already highlighted here for us. So the question is, what is the percent of goldfish that weighed at least 10 ounces? That is from here, from this cutoff, but no more than 14. So all between these two. So all we do, we are going to add the percentages, 34 and 34, which is 68%. The 68 that we already have here. Okay, I'm going to keep this this Bell diagram here, this Gaussian graph, and I'm going to keep here answering the question. So now they're asking, what percent of the fish weigh at least 8 ounces but no more than 12 ounces? All right, so at least 8, which is this part right here from 8, and I'm going to consider the 13.5 in the first place. Plus from 10 to 12, that's a 34%, but no more than 12. I believe this is going to be it, right? So we add these two together, these two pieces of chunk. Okay, so that's going to give us 47.5%. Okay. Then we're going to ask ourselves, what percent of the fish weigh at least 14 ounces? So at least 14 and on. So that is 13.5, 2.35, and 0.15. Okay. Now, let's see. If we add this together, we get exactly 16%. Okay. All right. What percent of the fish weighed at least 6 ounces but no more than 10 ounces? That means at least 6, which is from here, but no more than 10. That means we add these two chunks of the bell curve. That is 2.35 plus 13.5%, which adds up to 15.85%. All right. Okay, the tricky part right here. What percent of the fish weighed at least 11 ounces? All right. So here is where things are not going to work, because in this case 11, it's like right in the middle. Well, right in the middle between 10 and 12. However, one thing to keep in mind, this region is not perfectly rectangular or square, so we can just say, oh, it's about half of 34, which is 17 and on. So no, we cannot do that because of the shape of the curve. This right here, which is corresponds to 11, this is not half, and this is not the other half. This is larger area than this larger area, so we cannot tell in that case what the percent is going to be. So the answer here is cannot tell, but we will know. When we use the normal probability distribution, when we get to probability distributions, we are going to be able to use the normal distribution, and ask ourselves for the percentage of fish that weighed, I don't know, 13.7, or between 8.5 and 15.8. I don't know. Your preferred. Okay? But that's going to be a couple chapters further. Alright, so let's move to the next topic, which is measures of standing, rather, or position. So measures of standing, measures of position, either way. So some books call it standing, some other books call it position. So we are going to compare values to standard values. Alright, so what are we going to do here? So the z-score is the number of standard deviations a value deviates from the mean. Okay, so z-scores are also called standard values. That's another way to call these z-scores. And ultimately, these z-scores tells us how much whatever value deviates from the mean. Now, the formula to calculate, it's very simple. All we have to do is whatever value we want to know, subtract the mean and divide by the standard deviation. So for sample and for population, we have exactly same formula. However, what changes is the Greek letters for population and S and X for the sample. Okay. The rounding rule of z-scores is 2 decimal places. That's typically what we do. There are other distributions that go with 3 and with 4, but those are going to come later in the semester. So let's see, we have an example here. So the table here represents all the weights of all the cats at a cat show. Okay, so number 1, in this case, question number 1 is, do we have a sample of cats or do we have a population of cats? So here, because they're telling us all the cats at a cat show, it's all the cats. This is a population. If they told us, well, this represents the weights of 24 cats at some cat show, that would be understood that we would be talking about what is this? A sample. All right. So what are we going to do? We're going to find the mean and the standard deviation. And if you look back to the previous topics, well, finding the standard deviation is going to be a pain. All right. Look at how many elements in our data set do we have. I mean, even the mean, adding them all up, it's just going to be tedious. So lucky for us, we have calculator, and I already had this numbers for you. Okay, so it's 5 6 9 6 blah blah blah. Second quit stat calc one var stats, and in this case we don't need frequencies. You might want to clear this guy and calculate, and we get 7.37, and in this case I'm going to round this to 7.4 because we round to one more decimal than the given data. So the given data has 0 decimals, so we're going to round up to one more, which in this case is 1 decimal. All right, 1 decimal. So in this case, let's look at the standard deviation again. Keep in mind that there's 2 standard deviations. S that corresponds for the sample and sigma that corresponds to the population. So in this case, because we're talking about population, we're going to use the second one, 3.5. Okay, 3.5. All right, let's see. How are we going to use this? Okay, so let's find the z-score for the cat that weighs 13 pounds. All right, so this is what I like doing. Put the bar right in the middle, write down the mean, which is 7.4, and the standard deviation, which is 3.5. Okay, and in this case, let's calculate the z-score. So the z, formula z equals xn, which is the one we want to know. It's going to be plugged in there, minus mu over sigma. Plug in the numbers. Xn, which is 13, minus mu, which is 7.4, divided by 3.5. If you use a graphing calculator, you are going to get 1.6. Okay, what is this going to mean? It means that the cat in the cat show that weighed 13 pounds is 1 and 0.6 standard deviations from the mean. That is, this is xn equals 13 pounds. Alright, that's what it means. Let's look at the next one. So, what is the z-score of a cat that weighs 3 pounds? We do the same. State the mean. The standard deviation, 3.5. But in this case, we are going to look for values below. So, looks like 3 pounds. Well, let's see. First of all, plug in the numbers. Okay, no, not z, it's just z equals xn minus mu over sigma. Again, we are going to plug in this 3 over here. So 3 minus 7.4 divided by 3.5. And in this case, if we use a graphing calculator, if you do a calculator to simplify this, we get negative 1.26. So in this case, it's a lighter cat. Okay, so this means this cat is negative 1 standard deviation and this little tiny piece right there, which is not even half, right? It's just a little bit. And this is xn equals 3 pounds. Okay, let's find another score. Find the z-score of the cat that weighs 9 pounds, right? 9 pounds. 7.4, 3.5. Okay, so xn minus mu over sigma, that's the z-score. The 9 pound is to be plugged in here, and the mean and the standard deviation, 7, that's 9 minus 7.4 divided by 3.5. Okay, using a calculator we get 0.46. Okay. 0.46. So it's not too far away from the mean, almost halfway, almost half a standard deviation. So xn equals 9 pounds. That's what this means. Well, what about this one? Let's see. The z-score of the cat that weighed 7.4 pounds. Alright. Z equals xn minus mu over sigma. 7.4 is to be plugged in here, and mu equals 7.4. Sigma is 3.5. So if we plug in the numbers here, 7.4 minus 7.4, which is going to be 0 divided by 3.5, that's going to be 0. What does that mean? It means that this is the cat that is exactly in the average weight, the mean weight of the population of cats at the cat show. Okay, now let's see. Let's do this calculation the other way around. Now, they are going to give us the z-score, and then we are going to find what the weight of the cat is. Okay, so the weight of a cat is the weight of the cat that has a z-score of 1.25. So we know that mu is still the same. 7.4 sigma equals 3.5. All right, let's write down the formula first. Z equals xn minus mu over sigma. So in this case, I'm going to multiply both sides by sigma to get xn minus mu equals z sigma, or sigma z, either way, doesn't matter. I'm going to put sigma z just to go in alphabetic order, and xn will be sigma z plus mu. Okay, so we are going to use this new formula. If you want to call it a new formula, that's the formula to find whatever weight or whatever time, depending on the application, or simply solve the equation for whatever variable you feel you need to solve for. So in this case, let's find the score. Xn, what is the weight of the cat with standard deviation? 3.5, and z-score of 1.25 rather. All right, and then plus the mean, which is 7.4. Okay, so in other words, this is what it means. We are going to go 1 standard deviation and a quarter of it. So the cat that has that z-score will be xn. Let's find out. If we use a calculator here, we should get 11.8 pounds. I mean, there's no 11.8 pounds in our data set, but I mean, if we were exact and get the z-score that is 1.25, well, that'll be the cat. Okay, now let's look for the weight of a cat that has a z-score of negative 150. All right, so first of all, mu equals 7.4, sigma equals 3.5. So we're gonna go 1 standard deviation and in the negative direction, and half another standard deviation. All right, so xn, let's find out what that is. So we're going to use the formula. I'm not going to solve every time. Sigma z plus mu. So in this case, this will be 3.5 times the z-score, which is negative 1.50. Here the sign matters, be careful, plus the mean, which is 7.4. Okay, if we use a calculator over here, we are going to get 2.15, but I'm going to round this to 2.2. But just again, we are rounding to one more than what we have in the original data set. We have integers. We round all calculations to 1 decimal place. So 1 pound, 2.2 pounds rather, 2.2. Okay. Well, what is the weight of a cat that has a z-score of 0? Well, it's the cat. It's not any units, any standard deviations away from the mean. So it must be 7.4 pounds. No need to do any calculation because it's not deviated at all. All right. Unusual values. Okay. So we are going to have unusual values, aka outliers. Okay. If any cat is 2 or more standard deviations away from the mean. All right, let's find out. We're gonna go 1, 2 standard deviation. Anything bigger than that will be unusual. On the other hand, on the negative direction, well, not negative, on the left direction rather, because we're not dealing with negatives, that's going to be also unusual. Okay, let's find out the cutoff. Let's find out the cutoffs for unusual values. So again, keep in mind that the mean mu equals 7.4 and the standard deviation is 3.5, not 0.4. So I need to add 2 standard deviations. Okay, so I'm going to do that calculation here. Okay, so let me second quit. So 7.4 plus 2 times the standard deviation, which is 3.5. That's going to give me 14.4. Okay, 14.4. On the other hand, if I subtract that, I'm going to get 0.4. 0.4 pounds. All right. What does that mean? That means that any cat in the show that weighs less than 0.4, it's going to be unusual. Or any cat that weighs more than 14.4 pounds, it would be unusual in the show. Okay, so we're going to have from kitties to maybe lions or tigers. I don't know what this is about. All right. Okay, from the previous example, are there any unusual values? Okay, let's go back and look at the given data set. Okay. So, do you see anything bigger than or smaller than 0.4? So it looks like the smallest is 5. So in the left direction, there are no outliers. There are no outliers in the left direction. However, the cutoff for the largest values is 14.4. Do we have anything that bigger than 14.4? And it is right here, 20. So the outlier here is 20, seeing a 20-pound cat at a show. Not that it is impossible. I mean, given the statistics from these parameters, because we have a population, so we call them parameters. It's mu and sigma. So given under these parameters, it is unusual to have a 20-pound cat in the show. Okay. Okay. What else are we going to do here? Percentiles and deciles. All right. And so the percentile of a given value x is computed by using this formula right here. Okay. So that's one. They're going to asking us a percentile for certain number in a data set. Otherwise, they might ask you the value given certain percentile. I think the best way here is to just do a few examples. All right. So here again we have the weights of all cats at a cat show. Okay. And in this case, notice I'm giving you the numbers arranged from smaller to larger. All right. So what are we going to do here? Well, number one, they're asking us what percentile is a cat that weighs 18 pounds. For example, what about that about percentiles and all that? For example, let's see. If I have the numbers 0, 2, 4, 6, 8. Okay, so in this case, the number 0, well, in this case we are dividing, we have 1, 2, 3, 4, 5 places. Okay, so in this case, the 0 would be the minimum or the 0 percentile, or rather we can call it P0. Okay, P0. In this case, it's the 100% of the data divided by 5. That's going to be P20, P40, and P60. P20, P40, P60, and P60, P80. Well, let me add one more, otherwise we're not going to get 100%, and that's P100, right? So that means the number 6 in this list of numbers is the 60th percentile. It's the 60th place arranged in the scale from 0 to 100. So in this case, we are going to arrange, we're going to look at which cat is certain percentile and all that. Okay, what percentile is the cat that weighs 18 pounds? Okay, by looking at the data, it's almost 50%. It's almost 50% depending on how big the numbers are increasing. Well, so this is the visual that I like using for this. So I'm going to draw this, and below we have the first cat, and the smallest is the first cat and the largest of them is the 24th cat. The weight of the first cat is 2 pounds, and the weight of the heaviest cat is 47 pounds. Okay, so we are going to find the percentile, that is P of 18. Okay, so we're going to look for P of 18. So the percentile of the cat that weighs 18 pounds, I'm going to find which number is that going to correspond. Okay, so first of all, let's see. How do we calculate this? Well, number of values below x. Okay, below x, in this case, x is 18. X is 18. I'm going to count all the numbers until I get to the number 18. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait a minute. These are not arranged from small to large. I thought they were. So first of all, that's what we have to do. So let's see. Stat, edit. In this case, I'm going to use L2. It doesn't matter. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And then 3, 7, 11, 15, 19, 23, 27, 31, 35, 39, 43. Okay, so we have a total, am I missing one? Looks like I only have 3, 7, 11, 15, 19, 23, 27, 31, 35, 39, 43, 47. And over here, one's at the top, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Oh yeah, that's 12. And 3, 7, 11, 15, 19, 23, 27, 31, 35, 39, 43, 40, oh, 47. I need the 47. Okay, yeah, I thought I did it. All right, so we have 24 elements in our set of data. I'm going to second quit. I'm going to go to stat, sort A. from A. So we're going to sort these numbers from smaller to large. I'm going to click second and the number 1 to reach L1, because that's the number of column that in our data set. Oh, wait a minute, no, it's not L1, it's L2 this time. L2. Done. Now let's go to stat, edit, and we are going to see all the numbers now arranged from smaller to large. Okay, so going with the formula, number of values below x, that is how many values are below 18. Okay, so I'm gonna go all the way to the number 18, and the number 18 is 13, right? However, how many values are below? And below there are a total of 12, and in this case is divided by 24. This is exactly half, and I get multiplied by 100. Forgot the multiplication by 100, and I get 50. This means that the cat that weighs 18 pounds is the 50th percentile. Okay, that's a 15th percentile. In other words, it's a one right in the middle. What is the percentile? What percentile is what percentile is the cat that weighs 31 pounds? Let's do the same diagram here. One, 24, and 2, and 47. So the one that weighs 31, that must be a little bit higher in position, somewhere here. Okay, 31. So I'm gonna go to 31. 31 turns out to be the second, the 20th position. Okay, so P of 31 equals the number of values below the value that we want to know. In this case, if we have 21, one less, so there's 19 values below that. Okay, so it's the 19th, and then over here it was the 12th. Okay, divided by 24, multiply by 100, that's multiplication, and we get 79%. Okay, that means this guy is P79. That's the 79th percentile. Okay, let's look at another example here. So, what percentile is the cat that weighs 23 pounds? Well, let's do the same diagram. So 1, 24, because there's 24 cats. The lightest is 2 pounds, and the heaviest is 47 pounds. All right. So we're looking for the cat that weighs 23 pounds. Let's see. 23 pounds. So let me scroll to 23 pounds. 23 is the position 17, the number in parentheses. Okay, 17. Okay, so if we look for P of the percentile for 17 is the number of values below 17, which in this case is 16, and divide by the total, which is 24, multiply by 100. And in this case I get 67. This means that the cat that weighs 23 pounds is P67. In other words, it is the 67th percentile. Now we're going to look at the questions the other way around. Now we're going to look for the 40th percentile. How much, what is the weight of the cat this time? Whose percentile is 40th. Okay, so we have a couple of rules and exceptions here in the description on how do we use the formula. Okay, so all we do is multiply the percentile by the number of values in the set. So the percentile in decimal, okay, we multiply that in decimal. So in this case we want to know 40th percentile. So P40, it's the same as multiplying by 0.4. So x will be 0.4 times the total number of elements in our set, which is 24, and we get 9.6. Okay, now the rule is if we get a number that is not a whole number, round up to the next value in the set. Even if we have a 9.1, 9.2, I know if by the rounding rules it should round down to 9.0 to 9, but in this case we always round up. So in this case it's approximately the 10th cat. This is not the weight of the cat because that's the question. So what? We're gonna go to the calculator, okay, and we're gonna look for the 10th position. So the 10th position is the cat that weighs 14 pounds. 10 cat that weighs 14 pounds. Okay. We're gonna look at the next one, P65. Okay, so P65, that is the same as 0.65. Okay, so x equals 0.65 times 24, the total number of cats in our data set, and that's going to give us 15.6. But again, we round up to the next integer, which is the 16th cat, which weighs the 16th cat. Let me look for the 16th position. That's 22 pounds. Okay. P43. That's the same as multiplying by 0.43. X equals 0.43 times 24, which is the total number of cats we have in the data set. Okay, multiplying those two numbers, we get 10.32. Again, we get a decimal, rounded up to the next integer. Round up, even though by the rounding rules it would be 10, but no, we round up to the 11th cat, which weighs, let's see, the 11th position is the cat that weighs 15 pounds. Q1. What do we mean by Q1? This is a new term. Q1 is the first quartile. The first quartile is the same as saying P25, which is multiplying by 0.25. So x equals 0.25. Multiply that by 24. That's going to give us a 6. In this case, we are getting a whole number. We are getting a whole number. So how do we look for the cat? In this case, the weight of the cat. Okay, what is the rule first of all? If the result is a whole number, you take the mean of that value and the next value in the set, and the result is the percentile in question. Okay, so in this case, we got an integer. So we find the average or the mean of the weights of the cats in the sixth and the next one, seventh position. Alright, that is, we do the following. We are going to add L6 plus L7 and divide that by 2. Okay, so let's look for the weights of those cats. So we're going to go L6, well, not L from the column. So the sixth position, which in this case is 8th, and the next one, which is 10. And then divide that by 2, and the average is 9 pounds. So that's the weight of the cat, and that's because we got an integer as our x. Let's do more examples. Q2, which in this case is the same as saying P50, that's the 50th percentile, second quartile. Okay, that is 0.5. So x equals 0.5 times 24, which in this case it's going to give us 12th position, right? The 12th position. Again, we got an integer, so we're going to do the following. L12 plus L13 over 2. Okay, so let's go to the 12th position, which is 16, plus the next one, which is 18. Divide that by 2. And if we add these two numbers, we divide by 2, we get 17. Okay. Q3, that's the third quartile, or the 75th percentile, which means 0.75. X equals 0.75 times 24. And the answer to this is 18, another integer. So that means that we are going to go to L18 plus L19 and divide both by 2 to get the average. That is L18, which is 24, plus the next one, which is 27, and this is 25.5 pound cat. Okay. D3 and D7. Okay, this is another term called decile, and the prefix is decimal. You know, the third, this is really the same as saying P30, the 30th percentile. So x equals 0.3 times 24, and we are going to get, in this case, 7.4. And in this case, we no longer have an integer, we have a decimal. This is not a whole number, so we're going to round up to the next, and that's going to be the 8th cat, which is the one that weighs. Let's find out. The 8th cat in the list is the one that weighs 11 pounds. Okay. D7, That's the same as P70. 0.70. Okay, so x equals multiply 0.70 times 24 equals, in this case using a calculator, we get 16.8. Another decimal, we round up to the next one, integer, which is the 17th cat, which is the one that weighs, let's find out, 23 pounds. And this is, guys, what I wanted to cover on percentiles, z-scores, and the empirical rule. See you in the next video.